Hello, guys. Yeah, sorry for the silence for the first 10 minutes of this stream. I had to close a lot of windows I had open on my laptop. So I had like MongoDB, MySQL, and a lot of terminals were running, plus browsers were open. And I didn't want to start going into the stream and get to the point where the entire thing starts lagging. So I had to quickly um, close out everything. Yeah, some people will say, why didn't you just do it before it came live? It came on the stream. Ugh, guys, forgive me. But I've not even really been feeling too fine. Um, yeah, so you might even hear me cough, maybe cough and sniff from time to time. And that's because I'm not feeling too fine. Um, kind of have a bit of a flu. But um I can't complain. And I'm here today. So, guys, once again, welcome back to my um, live streams. And so, like you can see on your screen, we are going to be covering scoping rules, right? So it's not going to be like our other streams that take up to 2 hours. Today's one is going. I'm going to try as much as possible to keep it short. The reason for this is because the topic in of itself, I've done a great deal of summarization. So I just want to keep it simple and keep it sharp, right? So, guys, please, if you can hear me, consider dropping a comment in the chat box or saying something so I know that you can hear me. But I believe you guys can hear me. So, without further ado, um, let's dive into it. All right. So, like you can see on the screen, we are going to be talking about scoping rules in Rust, right? So let me just quickly share my. Let me, um, okay. All right. So we're going to be talking about scoping rules in Rust. Let me quickly edit this stuff. Guys, once again, sorry for the cough. Um, so from time to time you hear me cough, it's because I have a flu. So, all right. Yeah. So as I was saying, let me close out this caption. All right. Mhm. All right. So scoping rules, right? So basically, what scoping rules, what it covers, like this topic, what it covers is ownership. It covers ownership. It covers RAII. So RAII is short for resource allocation is initialization. It's a concept I'm going to briefly touch on. There's a very good there's I think about a 29-minute video from Computer File. I believe I watched that video some years ago talking about how Rust implemented the concept of RAII in the language, which makes it safe, right? Then we're going to look at borrowing, and we're going to try to master, um, you know, the art of memory safety in Rust, right? So as we usually do in all our live streams. So today we're going to create a new file, and this file I'm going to call it scoping rules. Again, I'm supposed to even do this before I come live, right? But here we are. So I have scoping rules, and yeah, so bring it in the lib file. So it's about that's just the shortcut stuff I do. To, yeah. So now I think we're done with that. So the only thing remaining for us to do is to import that file or any function from that place into our main function, our main file, right? Which is the entry point for every Rust application. All right, guys, please, if you can hear me, please consider dropping a comment or maybe saying something on Twitter. It really helps the video, right? It helps push it out to a lot of people who are, and yes, I'm also streaming on LinkedIn. I forgot about that. I'm also streaming on LinkedIn, so I don't know if people are streaming from LinkedIn, but I want to believe that people are actually streaming from LinkedIn. Um, don't have much audience there, but I just believe that I could share, um, you know, this sort of content on LinkedIn. All right. So the next thing I'll do at this point is to is to import that file into this place. All right. So scoping rules. So we have it here. So I want to import everything from that file. So we use the asterisk comma. So whenever we have a function that we made public, we'll then come here and find it. So we'll just add scoping rules here and for today's stream. All right. So yeah, I don't have anyone on LinkedIn. Interesting. LinkedIn is a weird platform. Anyways, yeah. So as I said, we'll be looking at scoping rules, and so basically, what this whole scoping rules, what this topic means is, um, we are going to be looking at ownership, RAII, like I mentioned, which is short for resource allocation is initialization. Resource acquisition. Resource acquisition is initialization. We'll also be looking at borrowing, and we'll be looking at some example of memory safety to enable us, drill down the concept of what we have, what we have looked at. So I'll just go ahead and close the rest of these files. I'm not using them for anything. So the first one, today I'll be doing a lot of copying and pasting because my streams are too long, and I don't want them to be too long. I want it to be short so that people can get more value for it, right? Because human beings don't have a lot of long attention, long time to concentrate on things. So I'm trying as much as possible to make these streams shorter. All right. So the first thing we'll look at is RAII, which is resource acquisition is initialization, which is kind of like um, it's kind of like an how would I put it? I'd say it's like an automatic way in which Rust handles variable lifetimes, right? So how long a variable lives in the scope of a program, right? So what this means is if a variable goes out of scope, Rust would automatically release the whatever resources that was allocated to it in memory, or that is associated with it in memory, right? An example of this is like, okay, we'll get to an example, right? But basically, Rust would automatically release any resource that is associated with that variable. So let's say we have like a file, and this file is we append it or we associate it with a variable. Let's say let file name, right, or let file type, right? So if we go out of scope, Rust would automatically release whatever resource that is associated with it, such as the memory or the file handles. So let's look at an example. So the first example we're going to sorry guys. So we're going to hypothetically, I'm going to try to drill down this concept. And there's a tool I would have used to show like real life example of how the RAII stuff works, but I will not be able to do it because I'm on a Mac and it's an M1, and there are issues with getting that package working. I tried I could not get it working on my Mac. So the name is Valgrind for those that are interested. And if you want to really dig deep and see how the whole resource acquisition is initialization stuff works, how the whole automatic resource management, how it works, you can take a look at that. So, but for now, what we'll be doing is so we'll be jumping between the main file and I'm jumping between the main file and the scoping rules file, right? So I'll close down that place. I don't need it. So first off, in order for us to demonstrate this, right, we'll create a sub main function. So I'll say fn. I'll call this sub main, and this function doesn't return anything. We just make it public, right? Doesn't return anything. Doesn't take anything. So I'll just make it public. Pub. The reason for doing this is so I'll be able to get it here. So in this place, I would say sub. So I have access to sub main here. All right. So the first thing I would do is I would create data on the heap, right? I'll create data on the heap, which so let's create data on the heap. So I'll say the first data I'll say let's box, because I'm going to use box for this example. So let box, I'll say box one is equal to box. Okay. So new, because we want to initialize data in it. And in here we'll pass a value. So let's pass like an integer of type i32. I32. All right. So you can actually see the implicit, type inference by Rust. So I would have actually automatically written it by myself. Another thing to take note of is whenever you're doing anything that has to do with type inference, it has to start with capital letter. So if it's a string, it has to be capital letter S. If it's a boolean, it has to be capital letter B, and the rest of them. So now I've defined box. So I've created this data on the heap, that is on the memory of my computer in this case. So now I'll go ahead. I'll just add a comment here and say this is heap allocated. Heap allocated. Heap allocated. All right. So this is heap allocated, and box one owns the data, right? So the owner of this data in this case is or owns the box. Owns the box in this case. Yeah. All right. Or I would call this, let's call this box two. Something just came to mind. All right. So everything in this place, right, is a scope. Everything between the curly brackets, right, everything from here to here is a scope. So we can create a scope, another scope that is nested in another scope. So we can create more scopes using curly brackets, right? So now we've created another scope, right? So this scope that we created, I'm going to say let's box, I'll call it box 3. And this time around, we're going to initialize it with a new value. So I would say box new. So in here, I would say let's pass 10, and let's make it a type of I32. All right. So now what we've done here is that we've created another scope. So remember I said we can define scopes. We can define new scopes between curly brackets, right? So everywhere you see a curly bracket is a completely new scope. So this is a completely new scope, right? Box 3 is not accessible outside of these two curly braces, if that makes sense. All right. So I'll add a comment for that. I'll say box 3 exists in the inner scope, right? Yeah. So it only exists in the inner scope at this point. Now, okay, can find function submain. Let's see. Okay. All right. So now, the moment we run this code, right, and it goes from line by line, unless it's asynchronous or something, and we get to this point on line 8, right? At this point, box is dropped, right? So I'll add a comment here saying at this point, box 3 is dropped. Right. Now let's move over to, let's take it a step further, right? Let's create a function and we'll call this function create box. And what this function will do for us is would loop like from like we'll create like 1,000 boxes, right? Using the for loop and stuff. We'll create 1,000 boxes, and I'll kind of hypothetically demonstrate where the drop happens in this case. So this is basically like scoping. Like in fact, that's what it is, right? So in order for us to do that, I'll say for, so because we want to like create multiple boxes. So I'll just put underscore here for box in so 0 dot 1,000. So the underscore between this doesn't mean anything, right? So it's still the same thing with have I done? All right. So the underscore you see here for 1,000, um, it's like it's just a way in Rust that we can be able to write clean numericals, right? So this makes it easy, like it makes it easy for me to read and know that this is 1,000 instead of me like trying to strain my eyes. An example of this could be, let's say, I want to do something like this, right? So I want to do something like so it becomes easier for whoever it is that is reading to read it. So it's still the same thing with joining everything together, right? It's still the same thing. So Rust just has a nice way for us to format it in such a way that it's easier to read. So just felt I should point out that important detail. So yes, so about that. So next we'll then go ahead and include our curly braces. And in this place, we'll call a function called create box. Remember, so we are going to create 1,000 boxes. So create box, and we'll just call it. So we've not yet created this box, right? So we'll just call it, and so I'll add a comment here saying, and this creates and drops 1K boxes. Yeah, thereby preventing leaks, right? Okay, so now before we move on, remember so we are seeing all these warnings here, right? And the reason for this is because we have unused variables. In order for us to prevent all these warnings and have like a clean working environment, we can just add underscore before this, guys. So add an underscore here and add another underscore for box 3, and if I save this, you see that all those warnings and stuff will be gone. Okay, so those are gone. So we only have create box because we have an error in create box because we've not actually created it. Like it's not found within this scope, right? All right. So one thing I want you guys to take note of is that in this particular example now, we have so many scopes, right? So we have the global scope. So the global scope is everything outside of the sub main function. Then we have the sub main scope, right? So that's where we have box 2, still valid here. Then we have another inner nested scope where we have box 3, right? So if you remember, take note that box 2 is still valid, right? Box 2 will only be dropped after everything in this place have run, right? So we've run everything here. We've created 1,000 boxes, dropped it, and we've gotten to this line. So the last curly bracket. So at this point, I'll add the comments here. I would say box 2, right, is dropped here. So this is where we end up dropping this guy, right? Because remember, this is his scope, right? The rest of these guys are nested in, have their own scopes nested in the sub main scope, while the sub main scope is, in the global scope. So now we'll create a function, and this function we'll call it, of course, create box. So I'll just copy this guy and say fn. So create box, and the box is not going to return anything. So we'll just say let's box 1, right? So initialize it and say okay. Somebody was sending me a message. So we'll say box new. So we initialize it with the new data, and here we would say let's pass 31 as a type of i32. So we've initialized it with the data. So I will just add a comment here and say this is a heap allocated int integer, so short for int, right? So this function would go ahead and create 1000 boxes, because remember, we are calling this guy here, right? We're calling this guy here. So what happens is, after that is done, the box one, right, will be dropped here. So I'll just add a comment saying box one is dropped here, thereby freeing memory. So thereby freeing memory for us, right? So if I go ahead and save this, I should not see these errors again. Exactly. So a recap of what just happened here. And this, what is happening here is all thanks to RAII, which is short for resource acquisition is initialization. So what it does is it's helps us to automatically free memory, right? So it helps us to automatically free memory, even in the case of loop like we just saw here, right? So a real world example of this would be let's say you went to a hotel, and you have, like, when you lodge in a hotel, you have like a key card, right? So once you check out, right? Once you check out, the scope ends, right? In this case, the scope will be your room, right? So the system would automatically, like, deactivate the key for you, which in this case would be when the resources are being cleaned up, right? Because there's no need for you to leave and still have access to that room, if that makes sense. So once again, just going over this, this is, in its simplest form, is scoping, right? um, where things are being dropped, like how Rust frees memory for us, right? So that we prevent things like data races and you know memory leaks, dangling pointers, and the rest of them. So this is what Rust uses to prevent that, and this is why Rust is such a top-notch language. In languages like C and or C++, um, you know, this is a very big issue, right? And this is a very big issue, especially the issue of dangling pointers and null references and all that, right? When you forget to free memory and all that, is a big problem. This is what Rust solves, for us. So next we are going to um, so guys, once again, please, um, if you find what I'm doing here, um, interesting, please consider dropping a comment or something just to support um, the video and get more audience for it. So next, we're going to look at destructors and the drop trait, right? We're going to look at the drop trait and then destructors. All right. So I might have been saying things like box one is dropped here, box two is dropped here, and box three is dropped here, right? Um, One thing to take note of is that there's a function that is automatically being called, right? So that function is in the prelude of every Rust application or Rust program, right? So the function is there, but you can't see it. So the function is in charge of dropping these guys, right? So in case you're wondering how the drop works, it's just something that happens under the hood, right, behind the scenes. So we're looking at a trait called the drop trait. So what I'm going to try to do here is to try and define a custom cleanup logic, um, you know, such that when we leave an object scope, we can, kind of see how the whole, drop functionality or drop feature works, right? So you don't have to bother about the drop function per se. Like I said, it is part of the Rust prelude. So it's something that is already in your program. You don't have to import it from anywhere, right? I think it will be available in std ops drop. I think so. Let me check. Exactly. So it's from the core library. So custom code with destructor. So the drop traits. There are a lot of things here to read, right? To go on. But you don't need to necessarily do this because it is already preloaded for you. In as long as the Rust application is running. So we're going to create a custom destructor. So I'll add a comment for this. Um, the comment. So okay, next here. All right. So what we want to do here is we want to implement a custom destructor, right? So what we are trying to do here is we're trying to go further to show how we can um, you know prematurely or um, how we can implement the drop functionality, like how we can do it on our own, like manually, right? If that makes sense. I know if I write the code, it will begin to make sense, right? I would say basically temporary or early call to the drop function or trait, whatever. So first, I'm going to create a struct. So I'll create a struct, and I'll call this struct temp. Let me say, let's call it temporary file. Temp file. All right. So I'll just define name and I'll use a string, right? So now we're going to implement the drop trait on it. So I'll say implement impl drop for. So I'm doing it for the temp file, right? So we'll write a function here. So this is our custom function, and to take a mutable reference to itself. In this case, the struct, and I'll just print something here. So I'll say print line, and I'll say deleting. Um, deleting deleting temporary file. Deleting temporary file. So I would say self dot file name. So yeah. So basically what I'm doing here, I'm trying to simulate a file deletion logic. So let's say here simulating a file deletion logic. So we'll still use our sub main function, right? So I'll just copy this guy, or just to keep the whole thing neat, I'll create a different one. So I'll call this pub and sub main drop. Sub main drop. So this is just so this guy would be pump fn sub main drops arguments this. All right, so this guy will be imported into here. All right. So here would then go ahead and pass data into our temp file, right? So we'll say temp file, and just remember this is just hypothetical example. So we'll say file name, and in this case we want to create a file name. So we'll say string new no string dot from, and here we'll pass in let's just pass a name, any name. So we'll just call it temp file temp.txx, and we'll close it. Right. Right. So I would say I will now like set this to a variable. So I'll say let's file equals to this. Right. So you can automatically see the struct is being implicitly passed here or inferred as the type. Right. So next I'll just do a simple print line, and in that print line I would say created temporary file. So created a temp file. And after this whole code is run, the file is going to be dropped here, right? So the file will be dropped here. So file is dropped here, and so it goes ahead to trigger the destructor. Just destruction, not destructor. Destructor, yeah. So if we should run this code, right? The output, guys, sorry for my cough. So the output would basically see here is we'll see created a temp file or created a temporary file, right? And we'll then see deleting a temp file. Right. So let's try to run this. Let me try to run this. Run. What's happening? Have a lot of warnings, lots of warnings. Okay, this, run it again. So what happens exactly? So like I said, right? I think my name is blocking stuff. Let me increase this. So I'll take it here. Okay. So if I drag this up and I increase holding it, so you can see that here we have created a temporary file and deleting temporary file.txt, right? So after this is done, right, after we've created that file, so we're creating that file here, and we've done the deleting, so we've simulated a file deletion like logic. The file, this is dropped here, right? So we dropped here. So why does drop matters, right? Like in this case, I would say guaranteed cleanup, right? So it's drop ensures proper resource release, even if a panic happens early, right? So even if like the application crashes or something, you know. So an example of this panic would be so let's say I just decide to panic the application here, right? So I'll comment this out. Don't know who is calling me. Anyways, let's continue. So let's say we decide to panic here. So there is a macro called panic. Panic. Right. So this panic, we'll just pass a string to it. So we say something went wrong. Something went wrong. And yeah. So take note that if we panic, the file will still be dropped, right? It will be dropped here. All right, but let's just run this. Let's see. Cargo run. All right, so we have okay, with similar. Oh, and small letter. It's supposed to be small letter. Sorry. It's supposed to be a small letter. All right, so close this, and I have to remove this stuff that my name is showing. It doesn't have to show again. Uh, Caption, customize. Guys, please give me a moment. I have to. Oh crap! Sorry. I don't know what I did now to kick out my. Okay, sorry. I'm trying to remove that name on the bottom left. Is it bottom left? I'm trying to remove that name. The name is blocking. At least from what I can see on my end, is blocking the this part of my screen. So this part of my. So I'm trying um to do that. Am I supposed to remove this? Am I supposed to remove this? Mhm. Am I supposed to remove this? Customize names. Okay, it has gone. Yeah. So sorry for that. Sorry for that. Anyways, so now I'll go ahead and run the code. So I'll say cargo run. Yeah. So panic early, and yeah. So what you can see here is so main thread panicked at blah 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 line 39 and all that. But you can see that deleting temporary file, right? So the file will still be dropped, right? It will still be dropped at the end of the day. But one thing to take note of is it will be dropped here. So the file is still dropped here, right? Even in a case whereby the application crashes or something, the drop still happens, right? So would still get that. For some reason, I can't see. Okay, I can see the error here. So this is the something went wrong, right? So this is the errors. As for a moment, I was looking for that, right? So something went wrong, and try to do the deleting of files, and the application just ended there, right? So for manual cleanups, guys, so I'll go back to my defaults. So I hate my code being too bold. All right. So one thing to take note of, right, is the fact that you would never, like, it is not advisable for you to manually do cleanups by yourselves. But if that's something that maybe you want to do, I don't know why. I don't know why. I guess there might be use cases why one would want to do an early drop, right, or manually drop by themselves. And there is a way for you to manually clean, like manually do like a manual cleanup or something. All right, so I'll just say manual cleanup. So you go to, it's available in standard library, so std mem, so memory, mem, and there you have drop, right? So you have this. So I would say use. If we add something like std, let's see if that's valid. Yeah. So if I hover over this, you can see that my little documentation I have in my VS Code, it says dispose of a value, right? So dispose of a value. This does so by calling the argument implemented of the drop trait. Remember, we did a drop trait implementation. I remember I said the drop trait is drop itself is already available in the application, so we don't even have to necessarily import it in our program, right? Because it's like a prelude. It's like some of the necessary things that are needed for a Rust environment to even run in the first place, right? So because I had to say this does so by calling the arguments implementation of drop. This effectively does nothing for types which implements copy. So I will talk about copy, the copy traits. Example, integers. Such values are copied and then moved into the function, right? So the value persists after this function call. So this function is not magic. It's literally defined as public fn drop. It takes a generic type of t, takes a value x, and takes you know t itself. So because x is moved into the function, is automatically dropped before the function returns. So it goes ahead to show examples, right? So this is a vector of integers, and then what's happening? So this is a vector of integers, and they did an explicit drop here, right? So it says explicitly drop the vector, right? Since ref cell enforces the borrow rules for drop, for at runtime, drop can release a ref cell borrow. So it goes ahead to talk about ref cells. This is like some of the things we'll handle, in our upcoming, streams and stuff. So talking about ref cells and the rest of them, ARC and mutual exclusions and the rest of them. So I just felt I should. So in a case whereby you want to explicitly drop something, right? You can use this, but it's something that is rarely done, right? So I'll just add a comment there for those that want to play around with this. So I'll call it manual cleanup. For manual cleanup. All right. Like this guy. All right. Um, so that's basically it, right? I can go ahead to like do an implementation for it, but I guess I've already showed that. But if you want to do an implementation for it, you can say let's create a file, and oh god, we'll use our struct. So temp file, and it's going to take an object. Remember, you have a file name, and that file name will just pass temp.txt dot intro, and that's this. Yeah, so we're doing this outside of a function. Let's just take it in here. Let's do it here. So I'll call this file 2. Okay. See if I take it out, if that would even work. See my mistake. Split that an item, exactly. Alright, so I will just take this and put it here. Clean up. Alright, so the next thing we'll do is we can then go ahead to manually drop. So we just use drop, and in that place we pass file, right? So what happens here is that the constructor, right? The destructor runs immediately. runs immediately, and then so let's say print line, and I'll print line to say file deleted before scopes end. Right. So what happened there is that before the scope ended, we just try to just the purpose of doing this is just to show that you can manually, or you can for some, but for a reason I don't know why, you can decide to manually do your cleanups by yourselves. I believe, I know that there will be use cases for that, but it's not something I've really looked into, right? But this is something that is doable, right? You can, you know, you can get the drop function or method and use it to do an early drop in your code or something, right? But by default, it is called based on scope, as we have seen here, right? So everywhere you see box 3 is dropped, that function was called, right? So the moment we left the scope, the inner nested scope in our sub main function, that function was called to do the dropping, right? To free the resources in memory, right? So because we know box is heap allocated, so the same thing happened here too, right? So when we created 1000 boxes by creating a function and doing all that, so it was also dropped here after we created each of those boxes and dropped created each of those boxes, right? It's after that had finished running, it's dropped them here, right? Then moved on to drop the last one, which is box 2 at the end of the sub main function. Right. So for some reason whatsoever, for any reason whatsoever, which like I said, I don't know, you might want to manually handle your cleanups. So this is the way that can be done. All right. Just for the sake of testing this, let's run this code. Okay, so I'll take out the panic. And so let's run it again. Not so something I even made a mistake. I dropped the file instead of file 2. So all right, so let's run this again. Exactly. So we have this part running first. So deleting temporary file, right? Which is temp.txt, right? It runs automatically because it is appended to, we implemented the drop traits on the temp file, right? And we are initializing the struct here with the values that we need, right? So it runs automatically, right? But what our focus is here, right? This is where our focus is. So if you take a look at what we have in the terminals, I'm going to increase the size of this. So you take a look at what we have there, and I'm also going to do this. Is it big enough? All right. So you see that we created another file. So we passed a file name into it, and we then called drop. Of course, we had gotten it from the standard library, right? So std memory, short for mem, semicolon colon drop, right? So that's how we're able to call the drop here. So drop, and we passed file name into it. Then we now just did a print. So what happened here? Say file deleted before scope ends, right? I'm deleting temporary file txt, blah blah blah, right? So yeah, that's like basically how the whole drop stuff works. I mean, it's definitely something that you should check out in your spare time. But believe me, the concepts, it gets easier the more you dive into it and you try to gain more knowledge about it. So next, we are going to look at ownership and how moves happen, right? So this is a very important concept in everything that we are doing. So add the comment here. So ownership and moves. So each value in Rust has a single owner, right? So if you assign it to another variable, you move, like you basically move who owns who owns that value, and this would go ahead to render the original value invalid, right? So this particular aspect is kind of dicey and can be confusing at times to understand, but trust me, it gets easier. Like I said, gets easier. So for example, we'll look at another example. For this example, we'll also create, I would say we'll create another sub function. So I would say pub fn. So I'll say sub main ownership move. It's a very long name, I know. All right. So now we have this function. In this function, we are going to create a string, right? So say so call it s1. So we do this. It says string from, and here we pass hello, right? So we created a string. So now let's look at some. So let's say we create something like s2, right? Let's say s2 is equals to s1, right? So what has happened here is that s1 has been moved. So everything that we have here has been successfully moved into s2, thereby rendering s1 useless. Not useless, sorry, invalid, right? So in other words, I would say, yeah, basically rendering it invalid, right? So if we go ahead and try to print this, I'll say print line, and I would do two things here, right? So first of all, I'll try to print s1, and then I will later on try to print s2. So this is, let's call it s1, that's s1 here, and then our function, we have to import it into the main. So we'll call it sub main ownership drops. Save this, and then for the rest of the guys, I would just comment them out because I want a clean terminal. I'll save this, cargo run. So you can okay, not found in scope, in this scope 946. Why? So let me say, okay, I did not save this file. Actually, I'll go run again. So you can see that so Rust is already telling us that there's a couple of issues with this stuff that we are doing here, right? So it's already saying borrow of moved value, right? So we moved the value, right? So it's saying borrow of moved value s1, right? So because we have moved this value here, we cannot be able to print it here to see what its value is, right? So it says so move occurs because s1 has type string, which does not implement the copy trait. So we'll get towards, like I said, copy and clone traits. We'll talk about that. So it goes ahead to say the value moved here. So this is where we did the moving, because remember we did like an appending, right? So we appended s1 to s2. So what happened in that case is that the value of s1 is now in s2. So it completely rendered s1 invalid, right? So now we're trying to say value borrowed here after move. So this stuff of clone is a different thing altogether, right? So what clone does is that it creates a new copy, right? It creates a new copy of what we have here, where we had initialized our string, right? But we're not interested in doing that. We just want to see, I just want to like show what happens when we do this kind of thing, what you should expect, right? And what you should expect when we do these sort of things. So next, we'll then go ahead and so I'll just add a comment. I'll say what's comment line there. So I'll just say get an error. S1 is invalid. Right. So we'll go ahead and create. And to take it a step further, we'll create a function. So call that function consume string. Consume string, and it takes a value. So we'll say it takes s2, right? In this case. So now, in this case, we've automatically, remember, the same thing that we're doing here, right? So we've automatically passed ownership to the consume string function, wherever it may be. Yes, we've not created it yet, but if we immediately passed ownership to consume string, right? So if we let me just add a comment saying ownership. So who owns it? So the ownership stuff is not rocket science, right? It's just owning. Who owns it, right? So now we've carried the data that we've declared to S2 and we've passed it into consume string. So consume string is now the owner of this data, right? So when I say ownership has moved to consume string fn, that is function, right? So if we come down here and try to print, so if you do print line, and we try to print S2, we'll get an error, right? We'll get an error. Basically to say error S2 is moved, right? So let me add an error here, and we'll still test this, right? We'll test it, so it's not like I'm just writing it and I'm not testing it. So we'll create another function called consume string. So I'll say fn consume string. All right. So this our consume string will just do something very, very basic. Remember, it's taking a value because we passed the value to, so we'll say s, and the type for that s is string. All right. And my spelling is wrong. All right. Doesn't return anything, so we'll just do a simple print line. And so just say consumed here. And pass our s, because remember s2 now became s. So take note that our drop would happen here, similar to like what we saw when we looked at what function, create box, right? So the drop happens here. So come down here to add that comment saying s, which is our value, right, which we passed, is dropped here, right? So because this has finished running, s was dropped here. That is why you can no longer get access to this. Remember, the code works sequentially, right? So it works. So remember, the code works sequentially, right? So because it's working sequentially, this particular guy has to run first, right? So um, whenever he's finished running, S is dropped here, is dropped, right? So because S is dropped at that point, we can no longer get access to it here, right? So yeah, I don't know if you guys can hear me. Right. So we'll go ahead and create, and to take it a step further, we'll create a function. All right. So sorry for the break in transmission. These things happen. So I had a glitch on my streaming software or device, whatever. Um, so it's kind of not letting me stream. I don't know what's happening. Uh, so, so guys, I might have to continue without the whole